Here we have the Perkin Elmer 881 far infrared spectrophotometer. Currently it's not under external control. That just shows you the turn on screen from the original standalone software. This is the sample compartment, complete with window, and here we have local PC control. We just launch the software and then we go to setup mode. So we're going to set up the scan parameters, scan method. We're going to scan with on comms port 1, Perkin Elmer 881. I'm going to scan with a double beam. We're going to look for transmittance. We're going to operate without checking the baseline, just at a 0% and a standard constant of 1, but we are going to scan the 100% to make sure the background is okay. So we are going to scan, let's say, from 8 to 12 microns, and we're set up in microns, not wave numbers. We're going to do it at a relatively coarse interval so that we don't spend a great deal of time scanning for this video's purposes. And we're going to draw the graph from 8 to 12 microns with a 0 to 100% transmittance and call it demo 1. Save it as scan 1. And okay, so we've got nothing in the beams at the moment. There's the two beam positions, nothing in the beams. And we shall now acquire the 100% reference. So we switch to external control and we start to scan to collect the 100% level to check the background. It takes a couple of minutes because dispersive spectrometers are relatively slow. You can see the scan in per centimetre, wave numbers, so the instrument is scanning and it is acquiring the reference data. Because we've got a 0 to 100% scale on the graph, you can see it just measuring the 100% level. A little bit of noise on there, but that's the speed at which we're scanning and such like. So once we've acquired the reference data for the 100% scan, we shall measure a sample. And the reference has just been acquired, so we've just come back from external control, and the sample that we are going to measure is a Perkin Elmer polystyrene film reference. We open the sample compartment, place the sample into the sample beam, sample beam reference beam, because it's a dual beam instrument. We select sample scan. We then acquire the data by running the scan. The screen turns red, data being acquired. and there you can see the plot of the relative transmission of the polystyrene calibration sample, which is used to calibrate wavelength and transmission for this instrument. And because we're running a relatively quick scan, there's some data obviously is going to be missing from this scan. There is a lot of absorption peaks that are in this sample that are visible that we're not going to pick up here because of the speed that we're running at. So there we have acquired the transmission spectrum from 8 to 12 microns of the Perkin Elmer polystyrene reference film, and we've transferred control back to the instrument from the computer, and then we can do whatever data processing we want to do on this spectrum.